My research involves big data analytics and business or business analytics. In this segment, I'm going to talk to you about a paper that I co-author with Professor Deepa Mani from Indian School of Business and Professor Inbal Yahav from Bar Ilan University in Israel. In this research, we actually develop a method for comparing the treatment effects or intervention effects in very large studies when you can't actually run a randomized trial. Typically, the best way to test or evaluate the impact of a certain intervention is to randomize people into a treatment group and to a control group, and then compare the outcomes of the two groups. But in many cases, it's impossible to do that. For example, one of the cases that we look at is an e-governance program that was introduced by the government of India in 2006. And they wanted to test what is the impact of this new e-gov initiative. So here, obviously, you cannot randomize people to force them to use the new system and force others to use the old system. Instead, what you have is a problem called self-selection. People choose which one of these new programs or the old program they want to use. Then, when we want to evaluate the impact of this new program, we have a problem. If we simply want to compare the new or treatment group to the control group, we don't know if the outcome is because of the treatment or because people chose whatever's best for them. In this example, the treatment was an online system. So if we simply take the group of people who use the online system and compare them to similar people who use the offline system, we still can't say whether it's the impact of the online system or that people chose the system that was better for them for some reason. In such cases, we have statistical models or econometric models that help us to try and fix for this problem of self-selection. A very common and popular method is called propensity score methods, and they're heavily used in different areas. The problem is that these methods don't really scale up well when you have very large experiments like this. These are called quasi-experiments. They also have a few other problems that makes them a little bit less useful when you have very rich and large data. This is what we call big data. We developed an alternative method that uses a machine learning algorithm called trees. And in this case, the tree can be deployed automatically on this very, very large data set, comparing the two groups and generating a set of matched groups, matched people in the treatment group and in the control group that are very similar in terms of the chance of choosing one or the other treatment. This method that we developed is nice because it can not only work with big data, it also works with small data. It's also much more transparent. So for a manager who wants to figure out what exactly is driving this difference between the two groups, the tree tells them what, for example, is different about the people in the online group compared to the ones in the offline group. When we applied our method to the eGov data that I just mentioned earlier, we discovered something very interesting. The types of outcomes the government was looking for was, for example, that the online treatment, the online system, would reduce the number of trips that people took, it would reduce the number of bribes that people had to pay, and these types of outcomes. If you just compare the online and offline users, you see effects of some magnitude on these different outcomes. However, when you use the tree method, which tries to adjust for this self-selection, we discover something very interesting. We discover that people who conveyed more awareness of these IT initiatives by the government had a different behavior compared to those who were unaware. And the impact of the online system for these people was the opposite than for those who were unaware. So by finding these more nuanced relationships between an intervention and an output, we actually can learn how to much better deploy new systems, how to intervene in more customized ways, and figure out how to better evaluate the impact of such programs. The paper is published in MIS Quarterly in the last issue of 2016, and the paper is called A Tree-Based Approach for Addressing Self-Selection in Impact Studies with Big Data.